Okay, this is lesson 2.4, day 2. Writing linear equations. We got through all of this good stuff yesterday, talking about slope-intercept form, point-slope form, practice writing equations when given a graph or just when given information such as the slope and a random point, or maybe we had to calculate the slope ourselves. And then we also tied in parallel and perpendicular lines and how we can write equations based off that information. Okay, so all we have left for the day 2 notes are the word problems, everybody's favorites. Because who doesn't love to connect math to real life? And, people are always like, oh my gosh, when am I ever going to need to know this? Here's your chance to apply it. You're an American, purchased an average of 113 meals or snacks per person at restaurants. This is way back in 1984. Way before your time, and my time too. All right, so in the year 1984, Americans purchased an average of 113 meals or snacks per person at restaurants. By 1996, this number was 131. All right, so just by those first two sentences, is this like a growth or a decay type of rate? Growth, right? We're getting more. Write a linear model for the number of meals or snacks purchased per person annually. Use the model to predict the number of snacks or meals that would be purchased per person in 2006. Okay, so I gave you a couple just like bullet points here to help you get started on a word problem. A lot of people struggle with these. And really, they're either going to be giving you guys 2 points on this linear model, or they sometimes tell you what the slope is and tell you a random point. But a lot of the times it's just they're giving you kind of 2 points in disguise here. So anytime you're given years, let the time start at the first year given. So the first year given was in 1984, unless they say otherwise. Sometimes they'll say let T represent year since 1980. Sometimes they'll do that. In this case, they don't. So we're just going to let T represent our years since 1984. Okay. I'm going to use a capital N. So I'm declaring my variables here to represent the number of snacks or meals purchased per person. Okay, because that's what we want to predict, the number of snacks or meals that would be purchased per person. And they tell us right here, write a model for the number of meals or snacks purchased per person annually. Okay, so if I'm letting T be my year since 1984, in 1984, 113 meals or snacks per person were purchased. So I'm going to call that year 0 because T is year since 1984, 113 meals or snacks. Okay. By 1986, this number was 131. How many years since 1984 is 1996? 12. Yep, 12. This number increased to 131. Okay. So now if I want to find my rate of change from 12 years after 1984, from the original 1984, I really just find my slope, right? Or I'd find my difference between the number of meals or snacks over my difference in the years, which is just calculating your slope. So let's go ahead and do that. So 18 meals or snacks, an increase over the time period of 12 years. Now I got a decimal. And remember, for word problems, it's okay to have decimals. And I put on the directions for this homework assignment, you can write decimals when the original problem is in decimals as well, and also word problems. So 1.5 would be how much my number of snacks or meals purchased per person is increasing each year. Okay? Because we know what it was from year 0 to year 12. Does that make sense? That's my rate of change over the 12 years. Look at your 2 points given to you. What do we notice about this green point?
It's a y-intercept.
It's our y-intercept. So do we need to do point slope form? No. We could jump right to slope intercept form. We could jump right to y equals, but I'm using capital M, y equals mx plus b plus 113. Okay, there's my model. So this will factor in. Oh, I used t, didn't I? Oh, good catch, Miss Hendrick. I almost used a different variable than what I defined. We need a t here. Sorry. T. So used to using x. T represents my year since 1994. So each year it's increasing about 1.5. And then we'll add in what it started at year 0 in 1994. We started with already that data of 113 meals or snacks per person. Now we can use this model to predict the number of snacks or meals that will be purchased per person in 2006. Okay, so my number of meals per person in 2006, what would I plug in for T? How'd you get that number? You're right.
Because it's how many years are from 1984 to 2006.
Good. So he just said it's the number of years since 1984. In 2006 would be 20 years since 1984. You can just do 2006 minus 1984 if you're not comfortable with that math. And okay, so we're going to plug in 22, not plugging in 2006. Again, this factors in how much it's increasing each year plus the amount we started with in 1984. And I got 146. Now remember, N represents the number of snacks or meals purchased per person. So 146 snacks or meals purchased per person. Okay, there's quite a few word problems on the homework, so you'll get some practice with this. This is very common in word problems where they kind of give you like 2 points. Now, if neither of these were my y-intercept, I would have had to do point slope form, which we practiced a lot yesterday. Okay? But life is great when we're given the y-intercept, and we can jump right to slope intercept form. Any questions on that one? Okay, last one here. Gosh, we need to update this data. All this stuff occurred before you guys were even alive. We need to like update it and like apply it to the population of like Fenimore and make this more applicable, right? I just took these out of the textbook and a little outdated. From 1990 to 1996, the population of Oregon increased by about 60,300 people per year. In 1996, the population was about 3,204,000 people. Write a linear model for the population P of Oregon from 1990 to 1996. Let T represent the number of years since 1990. Then estimate the population of Oregon in 2014. Okay, so I always start with defining my variables, and here they're being a little bossy. They're telling me we want T to be years since 1990. And I kind of like when they do that because then there's no confusion of what we should call T when they come out and just clarify. T is going to be my years since 1990. They want us to write a linear model for the population P of Oregon. So P is going to be my population of Oregon. Okay. Now this one's a little bit more interesting because of the first statement they tell us. They say from that time period, from 1990 to 1996, the population increased by about 60,300 people per year. They're telling me my rate of change there. All right, they're not telling me what the population was in 1990. They're telling me how much it's growing each year, which is what part of our linear equation? The slope, okay? They're giving me my rate of change here. So they told me my slope, or how much it's changing each year in that time period, is 60,300. See the difference with this one and the one we just did? They're giving me my rate of change. I don't have to calculate myself. The other thing they're giving me is what the population is in 1996. It was a little over 3 million people. Not a little over, that's pretty significantly over. All right, so in 1996, which if T is my year since 1990, that'd be sixth, the population was 3,204,000. I don't like to do commas with ordered pairs because then sometimes people get confused with which one's the x coordinate and which one's the y coordinate, but that's up to you. All right, so this time they gave me the slope and they gave me a random point. Is this random point my y-intercept? Sadly, no. So I'm going to have to use point slope form. Oops. Okay, so we're going to have to do y minus y1, which I'm going to use p, equals m t minus t sub 1. Okay, so we keep the capital P, keep the capital T. Now, I know what my slope is. It's 60,300. And I know a random point. I know that in year 6, so that's my T sub 1, the population, I don't know why it makes my finger an eraser, but it does. The population was at 3,204,000. Okay, so I'm going to use point slope form. Everyone see what I did there? There's my T sub 1, there's my P sub 1. They gave me that piece of information. Okay, now we're going to go ahead and distribute this number and solve for P to put this into our slope-intercept form. $60,300 times 6 is 361,800. And then I can finish by adding over this 3 million. If it helps you to put commas in now, you can. That's up to you. Whatever's going to allow you to make less mistakes. We get our model to be P equals 60,300 times T plus 2,842,200. So this makes sense because this is how much people were growing per year. So times by my number of years. We'll factor in whatever year we want to calculate, which in a second we're going to do 2014. Let me ask you this question. Based upon our model, what was the population of Oregon in the year 1990? Brandon?
2,842,200.
Good job. 2,842,200. That's our y-intercept. That's our initial population from year 0, which was 1990. Okay, good job. All right, only last thing you have to do is estimate the population in Oregon since 2014. So just be careful with this. 2014 is how many years since 1990? 24, yep. So we're just going to take our model. Oh, I love linear word problems. They're so fun. We're going to plug in 24. And it's good to kind of think of the math we're doing here. We're taking what our population was in 1990 originally. Then we're multiplying it by that rate of change of what it's increasing by each year. So over the next 24 years, to get to year 2014, it's growing 60,300 according to our trend here. So our estimation is 4,289,400 people. I got a little sloppy there, sorry. It's hard when I'm all the way zoomed out. Okay. So in word problems, define your variables. Be on the lookout for what information is given to you. Are you given 2 points, 2 like relations between different variables? Are you given the slope, the rate of change? And then write your model with either having to do point slope form, or if you're given the y-intercept, luckily, you can do slope intercept form. All right, folks. Fenimore folks, any questions? I bet you did a lot of word problems in Algebra 1.
Yeah.
So it feels like we'll do. Okay, I'm going to stop the recording here. Thanks for watching. That wraps up lesson 2.4.